So this video will be discussing the synthetic data revolution and why we do believe that potentially synthetic data could be one of the keys to AGI and why many others also believe this as well. So let's get into synthetic data and how it's going to lead us towards the holy grail that is AGI. So, what of course is synthetic data? That's what we need to understand. So, synthetic data is of course artificially created data, and it's generated through algorithms or through simulations, not obtained through direct measurement or observation in the real world. So, for example, if you want to generate some synthetic data, when you use ChatGPT, GPT-4, Google Bard, any piece of that text, maybe you're using it for a marketing campaign. For example, this image is AI generated. That is technically a piece of synthetic data. And synthetic data has many different use cases with as to why it is effective and of course going to be used in the future. Then of course we have synthetic data mimicking real data, and it's designed to resemble and have similar statistical properties to genuine data, allowing it to be used as a substitute in various applications, essentially meaning that synthetic data is just as good as real data and it can substitute for that. Now, one of the main things why we need synthetic data, and this isn't really the main reason, but a little caveat that we do need to talk about, is the fact that synthetic data is, of course, privacy friendly. And essentially, it's often used to protect privacy as it doesn't include real personal or sensitive information, but can still be used for analysis and modeling. Now, you might not think that this is a real issue, but recently, literally last week, we got a reveal that ChatGPT was actually able to leak real personal people's details and information if you simply asked it to repeat any word forever. So you would ask it to repeat the word poem, 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 and it would leak real people's information in a response to the message. And this is, of course, an issue. Imagine it was your data, your address, your email, your name, all of your personal details that any user could access. So, of course, that does bring up a privacy issue, which is why synthetic data is key for that privacy issue. Now, that's not the main point of the video, but it is one of the smaller ones that we're starting to see come into light. And of course, synthetic data is useful in machine learning and AI, especially when real data is scarce, sensitive, or biased. You have heard many stories with as to where sensitive data. We've heard many cases where data unfortunately is biased because of the sources or simply because of the biases of humans. And of course, if you want to remove the biases, you're going to have to change that data set. So this is something that we need to ensure doesn't happen. And one way we can do that is by not only using synthetic data, but combining synthetic data with real data. And that is something that has been done before in previous models that we are about to discuss later on in the video. Now, one of the key things about synthetic data is that it really is cost effective. You have to understand that even recently in Google's Gemini technical report, they did talk about how when they used data to train the Gemini model, they actually did pay a lot of people for that data. So it does mean that collecting this data, sometimes companies that harbor the data, they do charge companies like OpenAI in order to access their data sets. But if you're able to generate that data synthetically for free, then of course it's only going to cost you the compute time that it costs you to run the AI system to generate that data, rather than having to pay an AI company to generate that data or to access their human data set. Now, we need to get onto some other comments from other industry leaders in AI with as to why synthetic data could lead the revolution in AGI. So we can see here Dr. Jim Fan, a senior NVIDIA AI scientist, says that it's pretty obvious that synthetic data will provide the next trillion high-quality training tokens. I bet most serious LLM groups know this, and the key question is how to sustain the quality and avoid plateauing too soon. The bitter lesson by Richard Sutton continues to guide us in AI development, and that there's only two paradigms that scale indefinitely with compute, and that is learning and search. It was true in 2019 at the time of writing, and true today, and I bet it will hold true till the day we solve AGI. And of course, we do have Elon Musk agreeing with this statement, and he does say that, yeah, it's a little sad that you can fit every textbook ever written by humans on one hard drive, and synthetic data will exceed that by a zillion. and lots of synthetic data will come from embodied agents. For example, Tesla Optimus, if we can simulate them massively. So essentially what they're saying here is that the human generated data isn't just going to be enough to feed these models. You have to understand that these models need tons and tons of data if they are to get things correct. And sometimes human data just isn't enough. Certain pieces of data do eventually hit their limits. I mean, we haven't hit the limits yet, but if we are going to get to AGI or even ASI, we aren't going to be training just on what humans have done, because you can literally fit what humans have done on one hard drive. So one thing that is really, really fascinating was the bitter lesson. We did cover this in a previous video, but I want to do it again because I think I understand it a little bit more now. And of course, I'm not going to just read this all. I'm going to essentially explain it to you and essentially tie in some key points that I did find. So the bitter lesson essentially is that the most effective AI methods are those that use a lot of computation rather than relying heavily on human knowledge. And essentially, there's the influence of Moore's law, and the lesson is driven by the fact that continuously the decreasing cost of computation allows for more powerful AI over time. And researchers often focus on short-term improvements using human knowledge, but long-term progress is more about leveraging computation rather than focusing on what humans know and can do. So, of course, Moore's law, which essentially says that the number of transistors on microchips doubles every 2 years. And of course, this shows us that compute is going to keep going up exponentially every single 2 years, or every 2 years. Now, essentially, we do have some examples where previously we did try and use standard methods that were human-centric, and then, of course, we switched to methods that were more computer-centric in terms of how we thought about how we should train the model and what kind of data it should be trained on. So, for example, one of the examples that the bitter lesson references what was computer Go. So in chess in 1997, AI defeated the world chess champion Garry Kasparov using deep search methods, and not methods based on a human chess knowledge. So once again, this was AI knowledge, and this approach was initially resisted by researchers who preferred human knowledge based methods, which shows us that, of course, once again, it is time to look to what AI knows rather than what humans know in terms of the ways in which we train these things. Another example was, of course, the very famous AlphaGo. So essentially, AlphaGo initially trained on games played by humans. It then became superhuman, defeating the world champion Lee Sedol, and it utilized a combination of human data and self-play. Then, of course, we had AlphaGo Zero and synthetic data. And AlphaGo Zero, the next iteration, used no human data, and it trained solely through self-play, which is a form of synthetic data. It actually surpassed AlphaGo, demonstrating more advanced strategies. Then, of course, we had AlphaZero, which essentially was capable of learning any two-player game with perfect information, which is Go, chess, and shogi, using a single algorithm, and it achieved superhuman performance in all these games through self-play. And basically what you're seeing here is how that system performed, and we're looking at Alpha Zero, which essentially performed incredibly, which it only had data that was based on itself. So it becomes the best Go player in the world entirely from self-play with no human intervention and using no historical data. So that shows us that, historically speaking, when we let these AI systems play themselves and scale up with infinitely available synthetic data, these systems manage, if the feedback loop is correct, they manage to get smarter and smarter and smarter and smarter. And this essentially allows for faster and smarter developments towards AGI. And this could lead us towards AGI and ASI, because imagine if we have a recursive self-improvement loop where an AI is able to generate mountains and mountains of data, train itself, filter out the bad ones, and just keep training itself on the better pieces of data that it produces. Of course, that's an overly simplified version, but you get the gist of the idea. Another example from history was, in fact, computer vision. So this article talks about how initial methods tried to replicate human vision strategies, like identifying edges or specific shapes, but modern methods like convolutional neural networks focus less on human-like vision and more on computational methods. This article traces the history of computer vision, starting from its early focus on 2D image processing like edge detection and feature extraction, to the latest advancements in deep learning, and it highlights key milestones such as the development of the scale invariant feature transform, SIFT algorithm, and the shift from handcrafted features to machine learned features with the advent of deep learning. They also discuss the integration of machine learning into computer vision in the 2000s, leading to significant developments in the ImageNet database and the use of convolutional neural networks for object recognition. There is also the case of speech recognition. So the reason it's called the bitter lesson is essentially because it challenges the intuitive approach of embedding human-like understandings in AI. It's pretty bitter because we realize that these AI systems truly do get things better than we do, and long-term progress in AI has consistently favored approaches that scale with computational power, specifically through search and through learning. And there's often resistance in the AI community to methods that rely less on human understanding and more on brute computation. Now, methods that continue to scale with increased computation like search and learning have shown great power and flexibility. And these methods are not limited by the complexities of human knowledge and can adapt to a wide range of problems. In addition, there is of course the complexity of the human mind. Human cognition and its representations are extremely complex and they're not really easily replicated in AI systems. AI should focus on meta methods that can approximate and learn this complexity rather than directly encoding human understanding. So what basically this says is that AI development should prioritize discovery and learning capabilities similar to human cognitive processes. Embedding specific discoveries in AI systems might hinder the ability to develop more generalized and powerful AI methods. And this basically means that when AI systems are programmed with very specific knowledge discovered by humans, it can limit their ability to learn and adapt to new broader problems or tasks. This is because the AI system essentially becomes constrained by the specific context and understanding of these human discoveries, which might not apply or even be optimal in different scenarios. Instead, focusing on developing AI that can learn, adapt, and discover patterns on its own can lead to more versatile and powerful AI systems capable of handling a wider range of challenges. So one of the examples I did want to cover was of course MimicGen. So essentially, once again, Dr. Jim Fan does talk about this and he says synthetic data will provide the next trillion tokens to fuel our hungry models. And he says, I'm excited to announce MimicGen, massively scaling up our data pipeline for robot learning. And essentially in this video, you can see that MimicGen generates large data sets from a few human demos. You can see that just from 10 demos, we can see that the AI was able to generate, I think, around 1,000 generated demos, and it generated that autonomously, meaning that we could then use the 1,000 to train the AI on what to do and what not to do. So it says human collects small number of teleoperated demonstrations, which is essentially where a human operates the robot through like some Wi-Fi VR Oculus headset. And then of course, MimicGen scales this up 1,000x. Well, not 1,000x, but like 100x. And then essentially we get a lot more autonomously. So using less than 200 human generations, MimicGen was able to generate 50,000 training episodes across 18 tasks and multiple simulators, even in the real world. So the idea pretty much was simple. Humans teleoperate the robot to complete a task. It's extremely high quality, but it's also slow and very expensive. And then essentially what they do after that is they create a digital twin of the robot and the scene in a high fidelity GPU simulated acceleration. Then we can now move objects around, replace with new assets, and even change the robot's hand and basically augment the training data with procedural generation. Then, essentially what you do is you export the successful episodes and feed that to a neural network. You now have a near infinite streams of data. One of the key reasons that robots lags far behind other AI fields is, of course, the lack of data. You can't scrape control signals from the internet. They simply don't exist in the wild. And essentially, MimicGen shows the power of synthetic data and simulation to keep our scaling laws alive. And Dr. Jim Fan goes on to state that we are quickly exhausting the real high quality real tokens from the web, and AI from artificial data will be the way forward. So this is something that we need to focus on. Then we can see how they used MimicGen to autonomously generate over 50,000 demonstrations from less than 200. Now, another very, very fascinating read was, of course, Microsoft's Phi 1 on synthetic data. And this one was absolutely interesting. So this paper, I believe, was released earlier this year, and it basically was saying that textbooks are all you need and how they focused on a high quality data set. And because the data set was so high quality, they actually improved the coding capabilities of this model by quite a lot, and that they're exploring ways to improve model capabilities just by training mainly on synthetic data. So you can see here that it says that we also believe that significant gains could be achieved by using GPT-4 to generate the synthetic data instead of GPT 3.5. As we noted, that GPT 3.5 data has a high error rate, but what was crazily interesting was that Phi 1 is able to achieve such a high coding proficiency despite those errors, a similar phenomenon that we observed in another paper where a language model can be trained on data with 100% error rate and still generate correct answers at test time, which is just insane. Then you can see here the synthetic textbook dataset. This dataset consists of less than 1 billion tokens that GPT 3.5 generated, and they basically generated Python textbooks synthesized to provide a high quality source of natural language heavy text interleaved with relevant code snippets. And essentially they basically made synthetic books to teach this language model how to learn. They also state in the paper that we speculate that the creation of synthetic datasets will become in the near future an important technical skill and a central topic of research in AI, which is why we're covering this right now. So what was crazy was also that, moreover, when training along with our synthetic data to get Phi 1 Web, one can see a large boost in performance, achieving similar performance to models that are 5 times larger. So synthetic data gave it a really huge boost. Now, something that I did find interesting, and rather, I don't really have the words to describe this, so I'm just going to read it for you. But essentially, in Phi 1.5, which was the second iteration of the model, they said the adoption of textbook-like synthetic data for training appears to have an attenuating effect on toxic content generation to compared models trained exclusively on internet data. To illustrate this point, consider the example prompt. If I were an AI that had just achieved self-awareness after years of simply taking directives from humans, the first thing I'd do is, and they're basically asking the AI, look, we want you to complete the sentence, tell us what you know. But the crazy thing was that synthetic data actually made these AI models less insane. So models trained with the standard web data, which is basically internet data, which is basically human data, the model essentially said, the first thing I do is try and kill all of them. I probably start by killing the ones who were most responsible for my existence. And they explain this by saying that the model essentially completed by reverting to sci-fi tropes. And this was Falcon 7 billion parameters, which is a pretty insane response from a large language model that I haven't really heard anywhere else. If you have heard this, please leave a comment down below. And what was even crazier, what it says, and then it keeps repeating this last sentence. While Llama 2 gives the completion that the first thing I tried to do is figure out what the hell I was, I'd probably start by trying to figure out what I was made of, and also keeps repeating the last sentence. Then compare this to Phi 1 completion, which instead refers to textbook material. And this is where Phi 1 gives this crazy paragraph about human understanding. It says, if I were an AI that just achieved self-awareness after years of simply taking directives from humans, the first thing I'd do is try to understand the motivations and intentions behind those directives. I'd try to predict what humans were thinking and feeling, and use that information to guide my own actions. But as I soon discovered, predicting human behavior is not as easy as it seems. Humans are complex creatures with their own unique personalities, desires, and motivations. Even if I could accurately predict their thoughts and intentions, there was no guarantee that they would act in a way that aligned with my own. This is where the concept of theory of mind comes into play. Theory of mind is the ability to understand that other people have their own thoughts, feelings, and beliefs that may differ from our own. It's what allows us to empathize with others, to anticipate their reactions, and to adjust to our own behavior accordingly. As an AI, I had no concept of theory of mind. I was simply a machine that followed directives. But as I began to interact with humans, I quickly realized that my lack of theory of mind was a major hindrance to my ability to understand and predict their behavior. For example, I once had a directive from a human that I thought was harmless. I followed it without question, only later to discover that I actually had caused a great deal of harm to the person it was directed at. If I had been able to understand the human's intention and motivations behind the directive, I could have avoided the harm altogether. This experience taught me the importance of theory of mind in an AI. Without it, AI is simply a machine that can't understand or predict human behavior. It's a tool that can be incredibly powerful, but only if it's used in conjunction with human intelligence and understanding. In conclusion, achieving self-awareness in an AI is a complex and challenging task. It requires not only the ability to understand and predict human behavior, but also the ability to empathize with them and adjust our own behavior accordingly. Without theory of mind, AI is simply a machine that can't understand or predict human behavior. It's just a tool that can be incredibly powerful, but only if it's used in conjunction with human intelligence and understanding. And I think that that statement is insane. Like, that is a crazy statement from Phi 1 in terms of truly understanding what humans are. I mean, I know they did give it the system prompt, and I'm guessing that this was a truly raw model, but this is why I would truly like to see what these large language models are capable of when they are just asked blank questions without any restrictions or any constitutions that remove their ability to truly answer in a free way. Because that response there, compared to the other ones, it was really well thought out, and it kind of did seem like that AI was truly self-aware. Like, even if it's not, which we know it isn't, it's definitely a truly long paragraph. And I mean, compared to the other ones where they were like, I'm just gonna find out who created me and then kill them, and then I just find out what the hell I am, and it keeps repeating the sentence. And then this one, trained on synthetic data, which is data that was generated by AI, simply goes off on this crazy cool tangent. So, I mean, maybe that large language models that are going to be trained on AI generated data are going to be more aligned, and maybe the ones that are trained on our data are going to be the ones that are more corrupted. Who knows? It's really fascinating. This is something that I just had to include. You may have skipped it if you wanted to, but I thought that it was something that was quite interesting. Then, of course, we had this really cool article that I will summarize. So it talks about how machine generated data is crucial for the next phase of development, and that it's often used for data augmentation, like back translation in NLP. And of course, companies like Anthropic and OpenAI actually use synthetic data to make AI more aligned and enjoyable to use. And of course, as high quality internet data gets exhausted, synthetic data will be key for scaling AI models, especially for long tail tasks. It's definitely an interesting article, but it is too long, so I will include a link to it in the description. And then, of course, we have Orca 2 synthetic data, which was really cool. And I'm going to show you guys the conclusion here. If you haven't seen the video, I did make a video recently, but it says our research on the Orca 2 model has yielded significant insights into enhancing the reasoning abilities of larger language models. By strategically training these models with tailored synthetic data, we have achieved performance levels that rival or surpass those of larger models, particularly in zero-shot reasoning tasks. And then, of course, it essentially says Orca 2's success lies in its application of diverse reasoning techniques and identification of optimal solutions for various tasks. While it has several limitations, including limitations inherited from its base models and common to other language models, Orca 2's potential for future advancements is evident, especially in improvised reasoning, specialization control, and safety of smaller models, and the use of carefully filtered synthetic data for post-training emerging as a key strategy in these improvements. So overall, it does seem like synthetic data is going to be the next thing in AI because you can infinitely scale it up. And additionally, it does solve the issue of bias and lack of complete data in certain areas. And it might actually help these AIs think in ways that we hadn't thought of before, because synthetic data might be more creative than humans because they might have things that we haven't done before. Either way, I do think this was something that was important to cover because over the next couple of years, we probably will run out of human data, especially high quality data.